Hello, I'm Kayla Flager, and I'm here to talk about the DIY lava lamp experiment that we had. So this experiment is pretty simple. It involves dropping a tablet of Alka-Seltzer into a bottle that's filled with water and vegetable oil. My hypothesis with this experiment is that the Alka-Seltzer will react with the water and cause a reaction in the form of bubbles that will, kind of float up into the vegetable oil, giving us the effect that a lava lamp might have. For this experiment, we just need a couple of materials, so it's really easy to get together. We needed a bottle to conduct the experiment in. We needed water, vegetable oil, Alka-Seltzer, and it's not necessary, but add a little food coloring to make it a little more fun. The first step is adding the water and the vegetable oil to your bottle. I added my water first and then I added the vegetable oil on top of the water. However, it really wouldn't make a difference if you added the vegetable oil or the water first. And the reason is because water has a higher density than the oil. So the water is always going to be at the bottom of the bottle. The oil, it has a lower density, so it's going to float on top of the water. Most oils are made out of a combination of hydrogen and carbon, whereas water is made out of hydrogen and oxygen. If you take the elements that these materials are made out of and look at the atomic mass, you would see that carbon, which the oil is made out of, has a lower atomic mass than the oxygen has. So oil is made out of carbon and hydrogen. Carbon has an atomic mass of 12.01, whereas water is made out of hydrogen and oxygen has an atomic mass of 16 AMU. So the water with that higher mass, makes it a little bit heavier and it kind of sinks to the bottom of the bottle. No matter if you added the water or the oil first, you could shake it up, you could turn the bottle upside down, twist it all around, shake it up however much you wanted to, but that water is always going to end up at the bottom of the bottle once it has a chance to settle. So to begin this experiment, the first step is going to be dropping a tablet of Alka-Seltzer into the bottle and putting the lid back on. As you can see in this image here, this is the very start of one of the reactions. So when the Alka-Seltzer gets dropped into the bottle, it has a chemical reaction with the water, and we can observe that by seeing the bubbles that are forming, and these are bubbles of CO2 that are forming and floating up into the oil. The reaction is strong enough to push those bubbles up into the oil. However, since the water is more dense than the oil, they're always going to make their way back down to the bottom of the bottle. So it kind of creates a wave-like or I guess a lava lamp type effect where, the bubbles are moving up and down throughout the bottle at different paces. I continued to add Alka-Seltzer to the bottle. I added 2 separate tablets. One was the reaction taking place in the first picture here, and the other was the reaction taking place in the second picture. So you can see they had very similar effects. The amount of Alka-Seltzer that you add to the bottle would cause a more visual effect and a stronger chemical reaction because it has more of a reactant to cause those effects. Which brings me to my next point. Even though this experiment is really cool, there's a lot going on when you first drop that Alka-Seltzer in. The reaction is very short-lived. Each of these bottles had their reaction for, a minute at most, really less than a minute. And there is a reason for this, and the reason is because this reaction has a limited reactant. In this case, the limited reactant is the Alka-Seltzer. A limited reactant is the reactant that limits the limits more product from being able to be produced. So it basically kind of holds back that reaction. It's the first reactant that runs out. So in this case, there's plenty of water in the bottle. We could continue to drop Alka-Seltzer into that bottle, could drop the whole box of tablets in, and the water would still be there at the end of the day. That's called our excess reactant. And the Alka-Seltzer limits the reaction from moving forward because it does completely dissolve, and so that is why it is our limiting reactant. Um, so this was a great experiment. I really enjoyed getting to, see the effects of the things that we're learning in the class, and I look forward to seeing what else is in store. Thanks. Bye.